Once again, this is this video lecture is a part of रोशन पब्लिक स्कूल डिजिटल लर्निंग प्रोग्राम. आज फिर एक बार फिर आपका स्वागत है. Today we continue our chapter fifth surface chemistry, and today we discuss about the characteristics of the colloid. In our previous lecture we discussed about the preparation of colloid, purification of the colloids. Now we discuss about the characteristics of the colloid. In the behalf of this point, characteristics, we already discussed two characteristics already. One is Tyndall effect and another is Brownian motion. Today we discuss the important part of this characteristic, that is charge on a colloids. So basically, whatever kind of colloid is there, it must have charge on its surface. Charge is the mean of its existence. चार्ज नहीं है तो कोलोड भी नहीं है ना. चार्ज एग्जिस्ट करेगा तो कोलोड एग्जिस्ट करेगा. देखिए कैसे, तो कोलोइडल सॉल्यूशन आर इलेक्ट्रिकली चार्ज्ड. चार्ज ऑन कोलोइड इज बिकॉज ऑफ प्रेफरेंशियल एडजॉर्प्शन. अभी इसकी बात करूंगा मैं. प्रेफरेंशियल एडजॉर्प्शन क्या है बेसिकली. मान लीजिए कोई कोलोइड है स्फेरिकल शेप में ऑलमोस्ट. अब क्या है, इसके आसपास इसके सराउंडिंग में डिफरेंट काइंड के चार्ज रखे हुए हैं. चार्ज का मतलब आयंस अब इसे बोलते हैं. It may be sodium plus, it may be potassium plus, K plus, Na plus, Li plus. In case of negative charge, वो भी यहाँ होगा. It may be Cl minus. Okay. तो होगा क्या है, प्रेफर करता है कोलोइड, प्रेफर करता है चार्ज को एड्सॉर्ब होने के लिए. किस कंडीशन, क्या क्राइटेरिया होता है प्रिपरेशन का, वी डू नॉट डिस्कस अबाउट दिस बिकॉज इट इज नॉट अ पार्ट ऑफ योर सिलेबस. बट मान लीजिए इसने प्रेफर किया इस पॉजिटिव चार्ज को, रेड कलर के पॉजिटिव चार्ज को. इट मे बी Na plus, it may be K plus, it may be H plus. Suppose it prefer this positive charge so that all positive charges adsorb over the outer surface of colloid and form a layer. So now we call this colloid as a positively charged colloid. अब आप इस colloid को positively charged colloid बोलोगे. So basically इस तरीके से तो आपके दो तरह के आपके colloids हो जाते हैं on the basis of charge. अगर कोई colloid अपने outer surface पर positively charge को adsorb करता है, that's become positively charged colloid. And if some colloids adsorb preferentially negative charge on the outer surface, then that colloids become negatively charged. Okay. In this way, colloids can be classified into two categories: negatively charged, positively charged. So basically, what are the positively charged colloids? You can see here. Yes, metallic particles like copper, silver, and golds, and their salts. Okay, it's called negatively charged type of salt. Positively charged metallic hydroxide like iron hydroxide, chromium hydroxide, calcium hydroxide. तो ये सारा लर्न करने वाली चीज है, इसमें समझने लायक कुछ भी नहीं है. यू मस्ट नो अबाउट द hemoglobin, the kind of positively charged. All the basic dyes fall into positively charged category, and all the acidic dyes like Congo red and eosine are fall into category of negatively charged color. Along with the biomolecules like starch, gum, gelatin, clay, charcoal, and silicic acids, they all are categorized under negatively charged colors. Now we talk about the layers around the colloids. Suppose there is a colloid that is AgI. Preferentially, it adsorbs iodide ion on its outer surface. So basically it is a kind of first layer. Okay, it is a kind of first layer which is permanent and it is called a stationary layer, while the potassium ion layer, it is the outer layer and it is a mobile layer. That means it is not permanent. It may vary or change according to time. First layer is called a stationary or permanent layer, and outer layer or temporary or mobile layer is called, yes, it is called mobile layer. So basically there are two layers which surround a particular colloids, commonly known as Helmholtz इलेक्ट्रिक डबल लेयर है, दो लेयर्स हैं इसलिए इसको डबल लेयर बोला. नाउ आयोडाइड आयन की वजह से इसके आउटरमोस्ट सरफेस पर क्या है, स्टेशनरी लेयर का एक अपना इलेक्ट्रोड पोटेंशियल है जो कि नेगेटिव है, और जो आउटर सरफेस है मोबाइल लेयर है इसका अपना खुद का एक इलेक्ट्रोड पोटेंशियल होगा. दोनों के इलेक्ट्रोड पोटेंशियल में जो डिफरेंस होगा उसे आप जीटा पोटेंशियल बोलेंगे. So basically how would you define this zeta potential term? Zeta potential is the potential difference between stationary and mobile layer. So basically it is a kind of potential difference and all the potential difference have a unit measure in volt. तो ये जो है डबल इलेक्ट्रिक लेयर का फंडा है basically. Now we talk about the property which is basically due to charge, that is electrophoresis. We split this term electro and phoresis. इलेक्ट्रो का मतलब यहाँ इलेक्ट्रिसिटी आता है, हम इसे डिनोट करेंगे द मोमेंट ऑफ colloid particle under the influence of an electric field. Suppose we have to apply the external electric field if we fit a column with, if a column is fitted with the two electrodes, oppositely charged electrode, and maintain a potential difference. And if we put some samples of the colloids inside it, at that time, if colloid is carry positive or negative charge, either positive or negative charge, it moves towards the oppositely charged electrode, and that movement of colloid particle under the influence of an electric field is called electrophoresis और कैटाफोरेसिस. देखिए कैटाफोरेसिस पहले से बोला जाता था, ऐसा क्यों? क्योंकि इन एंशियंट टाइम बेसिकली we discover only negatively charged type of colloids. Negatively charged colloids आपने discover किए, and if we suspend these negatively charged colloid inside a U-shaped electrophoresis tube, then they move towards the cathode. जब कैथोड की तरफ मूव करेगा तो फिर आप उसे कैटाफोरेसिस बोलते थे. तो उस टाइम पे नेगेटिवली चार्ज क्लोराइड ज्यादा डिस्कवर हुए, उसका नाम कैटाफोरेसिस रख दिया गया. टुडे we called it as electrophoresis, the common term. Okay, so basically that's shown on your diagram कि एक U shaped tube है that fitted with the electrodes at their ends. One is negatively charged and another is positively charged electrode, and we put a colloidal solution here. Okay, in starting these colloid particles are evenly distributed throughout the solution or throughout the colloids, but after some time if you pass the electricity they move towards the oppositely charged electrode. Suppose this blue color colloids particle carry negative charge, then they must move towards the positively charged electrode, and after some time they deposited over the surface of positively charged electrode. That kind of movement due to electricity is called electrophoresis. Okay. तो इस तरीके से आप इलेक्ट्रोफोरेसिस को डायग्राम के थ्रू एक्सप्लेन कर सकते हैं. Now we have some little bit exercise here. The first question, define following terms: zeta potential and electrophoresis, that we already discussed. Second question, charge on a colloid is developed due to, guess what? तो चार्ज जो है बेसिकली प्रेफरेंशियल एब्जॉर्प्शन प्रिंसिपल पे डिपेंड करता है, उसकी वजह से डेवलप होता है. थर्ड क्वेश्चन, गिव द टाइप ऑफ colloids on the basis of charge. Basically there are two kinds of colloids, positively charged and negatively charged. To the course next question, that is 4, Right, importance of charge on colloids. So basically, charge on colloid is responsible for stability and existence of colloidal particles. The existence or stability दोनों के लिए responsible है, even though it is also responsible for Brownian moment. Okay, that we discussed in our previous lecture. So this is all our about today lecture, and I hope you enjoy this video. Have a nice day.